So our next function in the list is exponential functions. The type of function is called exponential functions, and of course the famous EX. But before we get to exponential functions, I'd like to quickly revise rules of exponents, simply because this is one of those things that is an important set of important laws in algebra that show up now and then. So let's talk about the rules of exponents. So here are some of the rules that you must know. If you have x and you have a power which is m over n, okay, that's the same as the nth root, okay, the nth root of x to the power m, okay, and we can write that again as the nth root of x like this as well, okay, all to the power m, okay, and of course you can also write it as x to the m to the power 1 over n, or x to the 1 over n to the power m. Okay, all of these are equivalent to each other. They're the same. Here's another rule. If you have a power and to a power, which I've actually done here, but let me just go over that rule. So if you have a power of a power, then that's the same as the powers multiplying. Okay, so if you had example, I'll show you examples of these in a minute. Let's just go through the rules first of all. That's one rule. This is the second rule. Third rule could be, and they're not in any specific order, x to the p, okay, multiplied by, not plus or minus, multiplied by x to the q. That's x to the p plus q. Okay, very important rule as well. Last one we'll look at is and then we'll look at some combinations that are possible. If you have a negative power, x to the minus p, that's the same as 1 over x to the p. If you have a product of two numbers and you raise it to a power, it's the same as x to the p multiplied by y to the p. It means the individuals are raised to the power. In a similar way, you could also have, okay, you could also have x over y to the power p, and that's equal to x to the p over y to the p, which is equal to x to the p into y to the minus p, if you like. Okay, but remember, x and y are not the same base, so you can't say p minus p. Be careful of that. So a quick example, a couple of examples. For instance, x to the 5 to the power 3 is equal to x to the power 15. Okay, 2 over third root of x is the same as 2 over x to the 1/3, which is the same as 2x to the minus 1/3. Okay, so here what's happening is, as first of all, the third root, okay, the third root here, okay, remember there's here, let me clarify one thing. 3 square root 3 or 3 square root 5 or anything is not the same as the third root of 5. Okay, this means 5 to the 1/3. This actually means 3 multiplied by root 5. So be very careful not to confuse the two things. Okay. Anyway, let's proceed. So I was saying here, if you notice in this one, what's happening is this is the third root of x, so that's x to the 1/3. Third root would mean 1/3. 2 over x to the 1/3. So I just changed it from that notation to this notation. Then as I move it up, move from here to upstairs on the numerator, whenever it crosses this line, you can think of this as a boundary. When you cross this boundary and go up or you come down, the sign of the power changes. So here it's a positive 1/3, it'll become negative 1/3. And I'll do a slightly complicated example. How about this one? 2 to the power x multiplied by, or 3 to the power x, let's say, multiplied by 3 to the 4 plus x all to the power 5. So let's have a look. So of course, rules of algebra, the first thing to do is to combine the two. 3 and 3 are the same base. So that will be 3 to the x plus 4 plus x all to the power 5. So first things first. So let's just do the inside first, because you could just multiply both of these by 5. That will also work. But here, let's just see 3 to the x. Okay, so what does that become? Let's have a look. Simplify that. It's going to be 3 to the 2x plus 4, and it's raised to the power 5. Now, power of power rule says powers multiply. Okay, have a look here. This is the rule I'm talking about. Power p to the power q. So here you have 2x plus 4 to the power 5. So this will become 3 to the 10x plus 20. Okay, that's our final result. Okay, I'm going back to the rules of exponents for a second. So I'm back here. One important rule that you must also know is any x to the power 0, anything to the power 0 is 1. A very important rule of exponents is that anything to the power 0 is always going to be 1. Our target topic, which is exponential functions. First, let's understand the word exponent. Okay, the key word here to understand is exponent. Okay. Okay, so in the previous example, the laws of exponents, the rules of exponents that I talked about, exponents is is a power. So x squared, this is the exponent. Okay, this is a power, so it's an exponent. Okay, but these are not exponential functions. So remember, a function is identified by the property of what is actually changing. So here the exponent is fixed. It's power 2, or x cubed, or 2 to the 3, or 5 to the 7. These are all exponents. These are the exponents of these numbers. Okay, it means the powers essentially. So what if, now here you see x is raised to a power, x is raised to another power, but the powers are constant. What if you turn it upside down or reversed this idea and said, let me raise 2 to the power x. So here what I'm doing is I'm switching the roles. Okay, so I'm going to take the power, I'm going to take a number, and I'm going to raise it to the x power. Now what's happening is the exponent, okay, the exponent is x. Okay, the exponent is x. This, any function like that, for instance, if I reverse the rules here as well, so this becomes 3 to the x. So this time the exponent is x again. So what's happening is now the variable is actually the exponent itself. I mean, the exponent has become a variable rather than a constant. Such functions are called exponential functions. Exponential. Why? Because the variable, exponent is a variable. Okay? Is a variable. So that's the first thing you need to understand, that e of x is not the only exponential function. It is one of the most well-known exponential functions, but exponential functions there are an infinity of exponential functions. 2 examples right in front of you here. You can have as many examples as you like. 5 to the x, 7 to the 2x, okay, 3.1 to the 7x, okay, you can have 2.178, okay, to the x, and so on and so forth, okay. So there's many different types of exponentials that you could possibly have. Exponential. Okay, so now let's get to the exponential function, the famous e. So let's define e. And e, we're later going to define it more formally when we study limits. But let's look at what is e approximately. E is something which is as follows. If I look at this particular specific number, where what I'm doing is I am taking some number n here. Okay, so I'm taking this number n here, and I'm raising it to the same n that's here. So these two are the same number. So example of this would be, for instance, an example is 1 over 1/10 to the power 10. Okay, if you look at that, that's actually approximately 2.5937. Okay, if I were to let's increase that. Okay, so what I want to do is say if this n gets larger, okay, let's see what happens if n gets large. Okay, n gets large. Okay, so here's an example. We used n equals 10. Let's use n equals 100, and of course these are dots here because these are irrational numbers. It gives us 2.7048. 7048 dot dot dot. N equals, let's say, 1,000, gives us 1 over 1,000 to the 1,000, and that's in fact 2.7169. And say n equals 10,000. Okay, and that's 2.718 1, and so on and so on. Okay. So as n gets larger and larger, you can see that the value is settling down. It actually is telling us that e has a certain value, and that's what I'm trying to show here. Okay, and it is in fact approximately. So e is approximately 2.71859, and it goes on and on and on and on. Okay, so this is the famous exponential, the famous the number e, and this is an irrational number. Okay, it's irrational. Remember, what is an irrational number? Let's please understand what an irrational number is. Irrational number is a number that cannot be expressed as a fraction. Cannot be expressed as a fraction. Cannot be expressed as a fraction. Remember that. It's very important to know that. As if these are very special numbers, the irrational numbers. The world's most famous irrational number is in fact pi. So let's go on a side for a minute here. Just on a side, I want to talk about pi. Okay. This is the usual notation for pi, the Greek letter pi. Okay, and it's in fact 3.141592654, goes on and on and on. It is the ratio of the diameter of a circle to its circumference. So if you measure the circumference of a circle using a thread or any circle, doesn't matter how big or how small it is, and you take its ratio with its diameter, okay, you will find that it always gives you this number. Okay, so what I'm trying to say is, so in other words, if you divide the circumference of any circle by its diameter, which is twice its radius, you will always get the number pi. And that's very interesting. Think about it. Circle of any size, no matter how big or how small it is. So this this circle compared to this circle, compared to this really tiny one, or a huge one, like like this circle, all of them, no matter what you do, if you take the diameter and you measure this circumference, okay, and you divide it by the diameter, you're going to get always the same number, no matter how big or how small the circle. So cool. This is really a very cool property of circles. Okay, and it gives us this irrational number. Now at this point, I'd also like to point out something very important, which is a fallacy and a very silly thing that people have learned over the years, which is that they consider pi, okay, as approximately this number 22 over 7. Okay, please try to forget you ever heard that, because that is an insult to the number pi. What did we say pi is? It's the world's most famous irrational number. What's an irrational number? A number you can't express as a fraction. I don't care if it's approximately this. Nobody cares if it's approximately this. The fact of the matter is, do not use pi as 22 over 7. Okay? Use 3.14, no problem, and stop that. It's up to 2 decimal points. Fair enough. But do not use 22 over 7. Okay? Please. It completely destroys the value of pi itself. Okay? It is an irrational number. If it was rational, it would be expressible as a fraction. So just, a side note on that. Now, in the same way as pi is an irrational number, e is also a very famous irrational number. So when you raise e to the x, you get the famous exponential function. This, I'm going to say the exponential function. Okay, this is the exponential function. Otherwise, 2 to the x, 3 to the x, 4 to the x, all are exponential functions. But this is the famous exponential function. All right, thank you.